Well Studio, we welcome now Gary Butler, founder and CEO of Camgian Corporation. Hey, Gary.
Hey, Gerard. How are you today? Greetings from Starkville.
I'm doing fantastic. So, first, congratulations on landing this sizable contract with the United States Army, $55 million. You've been awarded to develop advanced kill chain automation technologies. I think you've got some machine learning and AI technology embedded in what you're going to do as well. Tell us about that.
Yeah, well, thank you. First of all, thank you for having me on the show today. And just as background, we build enterprise AI software for both the government and the commercial markets. And that is to say software systems that leverage artificial intelligence, machine learning algorithms to drive faster, higher quality decisions within an organization. So as it relates to what we do on the U.S. military side, our specific focus is, as you mentioned, in this area of kill chain automation. So just for context, the kill chain is the process in the military of observing, understanding, deciding, and acting in a battlefield environment. So if you think about the enormous amount of data that's available today to our warfighters, from video to images from cameras, radars, and other sensors, manually executing that kill chain and that decision workflow can be very challenging, especially in times of conflict. So it's a very time-consuming, cognitively overwhelming process to our warfighters. So to address this problem, we have built a product called Reactor, which uses advanced artificial intelligence, machine learning algorithms to automate much of that decision workflow and thus close those kill chains much faster for a warfighter. So as it relates to this contract, we're leveraging this technology in air missile defense systems to more rapidly address large-scale aerial threats. So the kind of things you're seeing on the news today, from drones to swarms to missiles, and to assist our warfighters in delivering the right weapon to the right threat at the right time. So in essence, allowing our warfighters to target, engage, and defeat threats in a new paradigm, at machine speed as opposed to human speed.
That's fantastic. So Gary, does the solution incorporate some machine-to-machine communications where some machines, some sensors perhaps, just in the setting or collecting information and then transferring that, sharing that with other machines that are designed for other functionality, which then causes them to react and respond a certain way?
Yeah, exactly. So if you think about a battlefield today in air missile defense, you have a lot of different sensors, radar systems, cameras, as I mentioned a moment ago, but you have a lot of different countermeasure systems on the battlefield as well. And these can be deployed in different locations, different geographic locations. So being able to collect that data from a distributed perspective, share that information across all of these different platforms, and then track targets, ID targets, make decisions on targets. And we have algorithms that support what we call weapon-to-target assignment. So picking the right target to engage the right, picking the right weapon to engage the right target at the right time. So all of this works in a distributed fashion.
Wow. And, of course, when you're, I guess, removing the human decision-making process out of just the workflow, I would have to believe that you're also tremendously improving response times or reaction, just streamlining the entire process.
Yeah, that's correct. So I think the way you have to think about most AI machine learning technologies today is that from an engineering perspective, what we typically do is we look at that decision workflow, and that decision workflow comprises a lot of different tasks. And we can apply different algorithms to those tasks to automate much of that process and reduce the time it takes from collecting sensor data to making a decision. So yes, we can radically compress the timelines from the generation of sensor information to the time a weapon is engaged on a target, and we can take that in some cases from minutes to milliseconds. So in my opinion, closing kill chains faster is one of the most important things that we need to be doing in the military and it's something that we're certainly laser focused on here at Camgian.
So, Gary, I would assume then that this would enhance the prospects of success in a battlefield environment, and also you're taking some of the human risk element out of the equation.
Absolutely. So it's not only increasing the speed of closing kill chains, but also improving the performance in terms of making better decisions on the battlefield. And I'll just make one comment on that. I think one of the things we're seeing in modern warfare is the emergence of commercial technologies. And so historically, the development of advanced weapon systems have always been owned by the nation states, and that's because they had the money, they had the know-how, the people. But what we're seeing today, and I think Ukraine is a really good example of this, is that commercial technology is now making its way rapidly on the battlefield, from drone systems that are commercially available to AI algorithms that are openly available in open source, to communication systems. All of those things are available to everyone in the world today. So you're seeing these very advanced weapon systems being developed on commercial technology that have very robust supply chains, manufacturing processes, so they're exploding on the battlefield today. So you're starting to see this asymmetry starting to emerge now with this significant growth from commercial technology. So this type of kill chain automation is very important to addressing that problem.
So, Gary, is this kind of an indication of what we can expect in next generation warfare, that we're sort of replacing more conventional approaches, conventional weaponry with this sort of technology?
Well, I think the role of commercial technology in advanced weapon systems will continue to grow. For example, some of the most advanced algorithms today that are coming out of organizations and companies like Google, they're almost immediately made open source. They're online, so anyone can use them. And GPU technology, that's the most advanced in the world, is all commercially available. So all of these components that make up the future military systems are all commercially available today. So I think that the role of commercial technology will certainly play a much more significant impact in future war. Well, it's today and in future warfare, I would say.
So, Gary, would that mean that it'd be more difficult to maintain an advantage and an edge? So in my opinion, the warfare is changing at a very fast pace. And it's being driven by the adoption of these commercial technologies. So, for example, now you're starting to see proxies around the world be able to build weapon systems very fast at very low cost. So it's really a paradigm shift in how we think about warfare today. Yeah.
So yes, and I think when you look at sort of the long-term strategy of the Pentagon, this is certainly recognized, and much of what we're doing in the technology community is driving in this direction to address this new age of automation, machine learning technologies, what I would call algorithmic warfare.
Sure. Gary, to what do you attribute your success on this contract? Is there some proprietary technology you guys have, experience you have? What do you think is the reason that you were selected?
Great question. Gerard, we've been working in the area of counter-drone systems for quite some time now, and it's been very much an evolutionary process for us. We started with one contract, and we had success with it. We got more contracts, and they just kept feeding on themselves, and this problem has emerged as one of the top national security problems that we're facing today in the defense industry. So I think it's really a testament to the great work that our team has done, that the engineers within our company has done in delivering robust capabilities to our warfighters and the Army, and just that reputation that our team has built within the air missile defense community. So
wow.
It's not a recent thing. It's been evolving over time, but I would say that's the primary reason.
Yeah, and I know just from experience in the technology business. You don't do this in a vacuum with one person. It requires a massive team effort because, as you well know, you need such a diverse range of skills. It takes a lot of people to put all that together. One person doesn't possess all the necessary skills.
You're exactly right. And our team is very diverse technically in that regard. We have data scientists, we have software engineers, we have AI engineers, we have computer scientists in the company, and those make up the bulk of what we do. But, of course,
awesome.
It is a complete team effort with program managers and finance people, sales people. So it's a great team we've been able to put together.
Well, congratulations. I expect as well, we got to go, but I expect as well, Gary, this could be a springboard for future contracts, right?
Indeed.
Yeah.
We look forward to continuing to update everybody in Mississippi on our growth. So thank you.
Congratulations. We're proud of you being a Mississippi company as well. Thanks a lot, Gary.
Thank you, Gerard. Have a nice day. Bye-bye.
We're coming right back in the Element Wealth studio.